Hey, thanks for watching. This is my presentation on the thermohaline circulation. So first let's talk about what thermohaline means. That's a pretty weird word, huh? Well, thermo basically just means temperature, and haline means salt. And so for this demonstration I have this little miniature world map which I created. I know it's not the best, but it's what I'm going to use. And here's the Pacific Ocean, Indian Ocean, and Atlantic Ocean. And now the first process in the thermohaline circulation is that it starts out in the Atlantic Ocean. That's what we're going to start out with today. Now first thing is that there is water obviously in that ocean. And now this water is cold and it's also salty because when you know how we all know that it's cold up there, and so ice freezes. When that ice freezes, when that water freezes, the salt is not trapped in the ice. That's why you don't get salty glaciers. And also when water evaporates, it's not salty. It's not salty evaporation. The salt stays in the ocean. So the first thing we have to know is that the Atlantic Ocean is very salty. And so because of that salt, it can get pretty dense. And it can start sinking below the ocean surface. And that's the first thing that starts the thermohaline circulation, is the density of the combined forces of both the cold temperature and the salinity of that. And then that water will start to sink because of the combined forces of both the Indian Ocean and the Pacific Ocean. And then it will have this overlap loop that will make it start moving. And it will move, and it will eventually either end up in the Indian Ocean, or it might end up in the Pacific Ocean. Now if it ends up in the Indian Ocean, it will eventually get warmer, less salty, and then eventually it will finally sink back into the Atlantic Ocean. And keep in mind that all the water will surface sometime in its life. So just keep that in mind. But if it ends up in the Pacific Ocean, same thing. It will get less salty, and then it will finally go back, starting the whole process over again. And then it will end up in the Atlantic Ocean, where it will get salty and cold and dense and sink, and then go all the way back and repeat the process again. And then we will just have this continuous pattern. And now what is important to remember is that with the combined forces of both the Indian and Pacific Ocean, they basically act as like this pusher. And the important thing about the thermohaline circulation is that with this warm water from the Pacific and Indian Ocean, it basically acts as this main heater for all of Europe and some of the United States and Canada and Greenland and all those places. And this is very important because if we didn't have this, we would have an eternal ice age there and everything would be frozen. So that's what the thermohaline circulation is good for. And that concludes my presentation. I'd like to thank all those who watched.